So in the last video, we have created a GKE cluster on Google Cloud, and we been through some of the basic configuration of cluster during the setup, and we also set up the Google Cloud CLI on our local machine to connect the created cluster using the kubectl library. So in this video, we are going to deploy a containerized sample FastAPI application on the Kubernetes cluster. And we will be using the Kubernetes manifest and some of the basic, and we're going to learn about some of the basic configuration like replicas and labels and about services throughout the process. So let's start with deploying the application. So I have created a sample FastAPI app in, and this is the basic structure of my application. It has main.py file, which is nothing but a FastAPI application with the initialization and a simple route, which will give you this JSON in return if you try to hit this route, and a requirement.txt file with all the basic requirement like the fast API and UVCon to run the application. Then we have a Docker file, which is nothing but a containerized version of the whole application. And this is just a basic Docker file in which we are using Python 3.10 environment. And we are using exposing port 8080 as our application is running on that particular port only. Now we have one Kubernetes folder. So before jumping to the Kubernetes, I'm going to describe about what our Kubernetes manifest. So Kubernetes manifest is just a YML file that defines how a resource should be created and configured and managed within a Kubernetes cluster. And these manifests describe the desired state of the resource, such as pods, services, deployment, or any other Kubernetes object. And Kubernetes use these manifests to determine how to set up and maintain the resource running on the cluster according to the provided specification. And we usually use Kubernetes manifest for the resource deployment and basically to create, modify, and delete resource within the cluster for version control of the whole system and as well as the configuration management using the specification in the Kubernetes manifest file. So here we have like three file created. One is like deployment, one is namespace, and other one is service. So we're gonna start with namespace first. So starting off with namespace, namespace is just a logical division within the Kubernetes cluster that is just used to group or isolate same related resources. And the namespace concept helps in organizing and securing access to resources in a specific environment. For example, you can create a namespace for the staging environment or for a production environment, and both the namespace will are gonna be independent from each other and have their independent deployments and everything. So after namespace.yml, we have a deployment file. So this particular file describe how a deployment will happen on a Kubernetes cluster. Going from top to bottom, first of all, we have a API version. They specify the API version that we are going to use for Kubernetes. In our case, it's V1. Then we have a kind, which specify what kind of a resource we are indicating. It can be a pod, service, or a deployment. Then we have a metadata. Metadata is nothing but basically it describes a name and a namespace in which this resource will be created. And then we have a spec. Spec, here we mentioned replicas. So this specific key basically it means Kubernetes will try to ensure that there are always two instances of the specified pod always running on our cluster. So replica specify the number of pods that we want to run at a time on our cluster. Next, we have selector. So selector defines how the deployment will find which pod to manage. Then we have a template. In template, we have a metadata again. And in metadata, we have label. So labels are the key and the value pair that are attached to an object, such as a pod, services, and a deployment. and they are used to organize, select, and manage different kind of resources within a cluster. Labels also enable user to mark object in a way that makes them easier to locate and group by a certain characteristics. For example, if a particular pod belongs to a same application but a different environment, you can assign it a label as development or production or staging. After labels, we have another spec inside the template where we specify the container that we want to deploy. And here we have some specific key like name. So I specified a name as FastAPI app container. And then we have an image. So I have built this image and pushed that image onto a Docker Hub. So you guys can use the same image to try the deployment on your own cluster. So I specified the image name and the version of that image, and I specified the image pull policy. So this setting forced the Kubernetes to always pull the image before starting the container, which is it will ensure that always we have a latest version of the image that is being used for the deployment. Then we have a port number. So port number here we indicates the container will always listen to the specified port 8080. So you remember in the Docker file we have exposed port 8080. So our application is running on port 8080 only. So in deployment we have specified the same container port so that Kubernetes API can detect that our application is running on that specified port. Moving ahead, we have service.yml file. So service file is abstraction which defines a logical set, the pods and policy by which we can access them. And it is a kind of a abstraction that enables the external traffic routing onto the pods. And it also handles the load balancing across all the pods, and it have several functions. For example, it gives each service have a stable IP address which doesn't change if the even the pod has been replaced or a new pod has been created. And the second is like load balancing. So service provides a load balancing across all the multiple pods, and all the requests are distributed one by one in backend to the pods. And how service works? So in service we have a selector, which is our fast API app. So select you remember we mentioned the selector somewhere else as well, which is here in a deployment.yml file. So our Kubernetes engine API will club these resources together and identify as deployment as a selector for our service. And all the pods will be labeled with the fast API app label. And it will then provide us, the service will then provide us external endpoint, which we can use to basically check our application that is running or not and easily accessible on over the internet or not. So now let's start deploying all these resources using the kubectl library. So do so first we will navigate to the Kubernetes directory in which we have all the mentioned resources. Now I'm going to start the deployment using the namespace file. So the command for that is really simple. It is kubectl apply -f and the name of the file. So in our case, it's namespace.yml. If I hit enter, it will create a namespace name mlops onto our Kubernetes cluster. If I want to check if the namespace is created or not, I can simply do that by using kubectl get command and then mentioning the namespace. And you can check we have a namespace named mlops created onto our cluster. Now we will go ahead and start deploying our deployment.yml file onto our Kubernetes cluster. And again, the command is same, kubectl apply -f. Here we will specify deployment.yml file for the deployment. And we will ensure that we have specified a correct image path here, which is This is publicly available image, so anyone can use this image to deploy on their own cluster. So if I hit enter, it showed me like deployment has been created. So if I want to check the status of the deployment, I can simply do that by kubectl get deploy -n. -n represent the namespace that I want to check in, and I'll mention the namespace that we have just created. So, okay, my bad. So kubectl get deploy. Oh, wait, again messed up. So yeah, kubectl get deploy. And you can see we have the application running with the status ready. And we have two pods running of that specific application. But and if we go to our Google Cloud Console, and if we go into resource manager under workloads, we will be able to see the application here as well. And if we click on that, we will see all the CPU usage, memory usage, and the pods in the running status here. But the application is still not available on the internet. So to do so, we will be deploying our service.yml. So again, the command is same, kubectl apply -f service.yml. And as you can see, the service has been created on our cluster. So if we want to check the status of the service, we can simply do that by kubectl get service -n namespace mlops. And you can see the service is created with the type as load balancer. And here is the cluster IP. And if we go to the Google Cloud Console and refresh this deployment details page, you will be able to see that we have an exposing service here and with the name FastAPI service. And if we click on that, we can see here we have an external endpoint. And if we click on that external endpoint, then so it shows that our application is running now as we are able to get the output from that endpoint. So yeah, our application is now running on this external endpoint, and you can simply retrieve the external endpoint from the work under workloads and under the application that you have just created, then the exposing services, and here we have the external endpoint here. Yeah, so now if we try to hit the following endpoint, we can see our application is successfully running on the Kubernetes cluster as we are able to get the JSON from our FastAPI application. So yeah, we have successfully deployed the containerized application on the GKE cluster using the Kubernetes manifest. And in this video, we learned about some of the basic configuration that we have in Kubernetes API. We learned about replicas, labels, and services. I hope you like this video. Thank you so much.